Hi there, welcome to another video on the number conversion. Today we are going to discuss a little bit different, that is, we are going to convert a decimal number which is in fraction towards equivalent binary number system or any other number system. Right? I'm going to give you a simple example and let us see how we can proceed. For example, right, let us consider a decimal number 58.125. So this is a decimal number. So now I want this to be converted into a binary equivalent. So far we have focused only on the real number, not on the integer part, not on the fraction part. So now we have both a real and a fraction part over here. So we know how to do a real number, how to convert a decimal number which is in real part to its equivalent binary number. So for understanding purpose, I'm doing it. So if I have 58, so I'll be doing it like this, right? 58, I have 29, I have the remainder 0, then again I divide it by 29, so I have 14, then I have 0, then divided by 7, I have 0, then divided by 2, I have 3 2s are 6, so minus 1, again I divide it by 2, so I have 1 and 1, so I have to write it from bottom to top. So what would be my answer? This 1 1 1 0 1 0. So now this is for the real part alone. So this is for 58 alone. We have not completed 125. Now how to convert a fraction number of 0.125? So now I have 0.125. So this is my fraction number. Now I have to convert this to its equivalent binary number. The procedure is multiply this with 2. Right? 0.125 multiplied with 2 is 0.25. Now what you are going to do is leave the real part, take the fraction part alone. Right? Leave the real part, take the fraction part alone. So now I have 0.25 again multiplied by 2. So what I will get? I will get 0.5. Again leave the real part, take the fraction part alone, which is 0.5 into 2. What I will get? I will get 1.0. Now the procedure is I have to take the fraction part. So whatever I am going to do multiplied with 0, it would be 0. So now I have ended my conversion. For writing the answer, take the real part alone. Right? Take the real part alone and write from top to bottom. So how I'm going to write it? I'm going to put a decimal over here and write it 0 0 1 to the base 2. So if I write it on the whole, the binary equivalent of 58 is 111010. Decimal, the binary equivalent of 0.125 is 001. So this is my binary equivalent. This rule applies for if you want to convert into an octal. Instead of 2, you are going to multiply it with 8. If you want to convert into hexa, instead of 8, you are going to multiply it with 18. That's all the procedure. You know this procedure, you know the same, it remains the same. So now turning back, how do I convert a binary equivalent towards equivalent decimal number? Very simple. So again, for real part, you know how to do, right? So it is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5, it goes on like that. So if you add all that, you will get 58. So for decimal, for fraction, what you are going to do is, you are going to go like this way. Remember, it is 2 power minus 1, 2 power minus 2 and 2 power minus 3. So 2 power minus 1, 1 by 2, 1 by 2 into 0, it is going to be 0. Then you are going to add with 0 into 1 by 2 square, again it will be 0, plus 1 into 2 power 3, 1 into 1 by 2 upon 3, so it would be 0.125. So we got the answer back. Right? This is in decimal. So this is the trickiest part that you have to remember. Right? So I repeat, from if there is a point, right? If there is a point over here and you have some variables, numbers over here and over here, whatever the radix is, right? Maybe a binary or octal or a hexa. So here you are going to start from for the radix power 0, radix power 1, radix power 2. It goes on like this way. And from the fraction, it is going to go like this way. So you will start from radix power minus 1, radix power minus 2, radix power minus 3. This radix R can be either binary, octal or hexa. Got it? So this is the number conversion of a decimal number system which is in fraction. You can convert that to any number system. All you have to know is what is the radix and what you are going to do with the fraction. We'll see some problems. Okay, now consider this case where 2.325 to the base 10 should be converted to a binary equivalent number. So I know how to convert the real part, right? I have converted the real part, that is not an issue. Now see 0.325. So if I want to convert that into binary, I have to multiply with the 0.325, the fraction part, into 2, and I'll be getting 0.65. So this is done. So I'll be doing this process. See 0.65 into 2, it is 1.3. Then I'll take the fraction part alone, 0.3 into 2, I'll get 0.6. I'll take the fraction part alone and then multiply it with 2, I get 1.2. Then I get 0.2 into 2, I have 0.4. I'll take the fraction part alone and then I'll get the answer. 0.8 into 2, I get 1.6, I get the answer. Now I'll take the fraction part alone, 0.6 into 2, I get 1.2. Now look here, there is a, I just want you to observe, here we have 1.2 and here also we have 1.2. So this is the factor that you have to stop with. So you will be keep on proceeding it until you find a common number which is available after the fraction multiplication. So I will be stopping my result up to this particular column because I will be getting 1.2 repeated, right? The 1.2 is repeated. So I will be stopping with the above result, and now I can write the fraction part considering the real part alone. So what is it? From top to bottom I have to write, it is 0, 1, 0, 1, 0, 0, 1. So what was the, this is the fraction part, and for 2 it is 1, 0. Now this is the binary equivalent number. So you do this, if it proceeds for a longer period of time, you can stop with 6 decimal digit. That is enough for academic purpose, right? So but you have to proceed it. So at one point of time you will be getting a data which is matching with the previous value. So stop with that. So in that case you have to get this result like this. Hope you have understood. The same is for the other radix also, octal and the hexa number system. With this, the number system gets completed.